In this video, we're going to look at graphs. So this is probably going to be a review from what you learned in middle school. But let's start by looking at the parts of a graph. All right, so every good graph has a title. So up at the top here, we have our title. Our title in this case is bacterial growth at 72 degrees Fahrenheit. But you'll often see titles, especially in physics, written out as the dependent variable versus the independent variable. Next are our axes. On the bottom, our horizontal is our x-axis. Our vertical is the y-axis. Notice they're labeled. So I have here on my x-axis, it's listed as time, and the units are hours. My y-axis, I have the number of cells. The scale are the numbers on my graph. And if you notice on my graph, everything is spaced out. So my numbers are evenly spaced out. So the distance between here, 0 and 1, is the same as the distance between 3 and 4, 8 and 9. So all those distances are the same. Every time we create a scale, we want to spread all of the numbers out, and we want to make sure that the distance is equal. The other thing that you'll notice on the graph is we have data points. So, for example, let's take a look at a point. Let's take a look at this point right here. Okay, so at 8 hours, we have 256 cells. So that corresponds to a spot on my y-axis. So because it's so hard to read in this case, they went ahead and put the number on the line, but you won't always see that. So if you go up from the x-axis to the line and then over to the y-axis, it should match up with a point. The other thing that you'll see on this graph is the origin. So 0, 0. So 0 on the y-axis, 0 on the x-axis. So those are the different parts of a graph. All right, let's talk about variables. So on a graph, you're going to have two things. You're going to have an independent variable and a dependent variable. So an independent variable is the input value of the function, also known as the cause. So for example, if I drink a bunch of cups of coffee, that is completely independent. That action doesn't depend on anything else. The dependent variable is the output value of a function, or the effect. So if I drink a bunch of cups of coffee, which is the independent variable, the dependent variable, the output or the effect, is the caffeine level in my body is going to rise, especially if I drink a lot of cups of coffee. Let's look at an example. So it says, over the summer, data was collected for ice cream sales and the number of hours of sunshine. Based on the data below, identify the independent and dependent variable. So on our graph here, or on our data table rather, we have hours of sunshine, ice cream cones sold. So hours of sunshine is going to be our independent variable. Ice cream cones sold is dependent. Let me explain why. So if I sell four ice cream cones, that doesn't relate to 2 hours of sunshine. But if I have 2 hours of sunshine, usually I'm going to sell about 4 ice cream cones. So the number of ice cream cones sold depends on how many hours of sunshine there are. So again, look at 7 hours of sunshine. I was able to sell 10 cones. So the more hours of sunshine, the more ice cream cones sold. So the cause is the hours of sunshine. The effect is the number of ice cream cones sold. Okay, so line graphs are used to show change over time. I have a graph to the right that shows the recycling rate of different materials in the United States from 1990 to 2015. We've got our independent variable on our x-axis, which is going to be the date. This is our independent variable. And our dependent variable on the y-axis is the rate. So why is it helpful to see data in a graph instead of simply listed as numbers in a data table? Well, if you look at this graph right here, you can clearly see that all of the recycling rates are going up. Metal's going down a little bit, but paper and glass, actually glass is going down slightly too. Paper and plastic are both going up. Metal and glass are going down slightly. if I was just looking at numbers, it would be a lot harder to see that. So having a visual is very, very, very helpful. Gives us a quick glance. We can come up with trends that we see on there. So it just makes it a little bit easier for the person looking at the data to look at a graph than to look at a data table. So let's talk about slope. Slope is a number that describes both the direction and the steepness of a line. To calculate slope, we use the formula rise over run. Another way to calculate slope is to break that down a little bit further. We need 2 points. We're going to take the second y point and subtract the first y point and put that over the second x point minus the first x point. So whatever you get when you do the math there, the slope, if it's positive, if that's a positive number that you get back, your slope is increasing. So from left to right, your slope's going to increase. So your line will look something like this. Your slope will be positive. If you get a negative number, it's going to be decreasing. So your slope will look like this. So from left to right, your slope's decreasing. If your line is horizontal, your slope is 0. And vertical, it would be undefined. So for it to be undefined, you're going to have some number, let's say like 8 over 0. That would be an undefined slope. And of course, horizontal, it's going to be any number, 0 over any number. Well, again, we'll just use 8 there, for example. So those are the outcomes of slope. So let's calculate slope here. So it says calculate the slope of the line with 2 points, 2, 4, and 3, 5, and identify the line as increasing or decreasing. So our formula is y2 minus y1 over x2 minus x1. So let's go ahead and let's label the different parts here. So we have x1, y1, x2, y2. So y2 is 5. y1 is 4. x2 is 3. x1 is 2. 5 minus 4 is 1. 3 minus 2 is 1. So 1 over 1 is just 1. Since it's a positive number, our slope is going to be increasing. Okay, another thing that you're going to see on scatter plots or line graphs is a trend line, also known as the line of best fit. This is a line on a graph showing the general direction that a group of points seem to follow. So when we draw a trend line, we want to try to have the line as close as possible to all points. So if you look at the example here, that line kind of goes through all of those middle points. You want to have the same number or a similar number of points above the line and below the line. So in this case, we have 3 points above the line and 3 points below the line. The line does go through a couple points, but again, we're just trying to get it as close as possible so it's even on both sides. So let's take a look at 2 graphs here. In this first graph, the question says, based on the graph, what conclusions can you draw? Well, I'm going to sketch in a trend line here. So something like this maybe. So if you notice, it's close. I have about 3 points on the top. I've got a little bit more, maybe 5 on the bottom. But this just gives you a rough idea of what's going on here. So we're looking at the temperature, which is our independent variable on the bottom, and the number of visitors at a beach. So it looks like as the temperature increases on this graph, the number of visitors also increases, which makes sense. I mean, if the weather's nicer outside, more people are going to go to the beach. So we can draw that conclusion from the graph. Let's take a look at another one. Okay, so this one already has a trend line drawn in here. It says, based on the graph, what conclusions can you draw? So this is a graph of training runs. So this would be maybe somebody going out training for a marathon. They're out there running. So the time in hours is our independent variable on the x-axis. And on the y-axis, we have the distance. So depending on how much time we spend running, how much distance we covered. So it looks like as the time increases, looks like as the time increases, the distance also increases in our graph. So, I mean, that makes sense. If I have more time to go out and run, I'm going to cover more distance. And those are the basics of graphs.